Okay, let me start with some blackboard stuff. Okay, so let me see what we do exactly. Okay, so we have to start the laws of vector addition, right?
Yes, sir.
Laws of vector addition. Now, laws of vector addition is the basis of definition of vector. It means anyone who will not follow these law will never be categorized as a vector. For any physical quantity to fall into the category of a vector, they are bound to follow these laws. So our intuition of vector may be anything, but the mathematical intuition of vector lies in the fulfillment of the definition. Unless any vector is not fulfilling these definitions, whatever may be your intuition towards the vector or that physical quantity, it should not be categorized as vector. So it is all about the laws fulfilling physical quantities. So for example, if I say, let's say there is a current of 2 ampere, and let's say the current is flowing within a wire. So now no matter it is having magnitude and direction, we cannot call it a vector just because it happened to have direction. I mean, it happened to has direction and magnitude also. So you cannot say it's a vector because at the end of the day, it will not follow the rules laid out by the mathematician. So there are two ways to perceive vector. One is of course, the geometrical view, but other is like the mathematical view, which is the abstract view. So now we are comfortable with only one view, which is the called geometrical view. We are happy with the arrows and lengths and everything. But mathematically, it's more rigorous. Okay, so we have a separate branch of mathematics called the linear algebra, which talks about the vector spaces. And we have a slightly advanced theory as well called the group theory, which is a bigger, you can say, domain, and the vector is a subset of that domain. So there are various things. Vector is something really huge actually. I mean, if you learn the advanced computation, machine learning, AI, all this uses the concept of vector. But of course, when it comes to the advanced level of vector, they don't use what we learn in class 12. Like we don't, I mean, of course, they use those things also, but that is a very small part. So they what they do is they develop from the basic like geometrical view, and they keep on developing the abstract view also. So abstraction in mathematics always results into the lack of, it will remove the intuition. So with the moment the mathematics will introduce the abstraction, your intuition will go away. So it's difficult to visualize things. It's very hard actually. So since our syllabus is very much restricted to the two-dimension and three-dimension vectors, so we will not face those difficulties. So that's the good news. Okay, we are not going to face any difficulty of abstraction. For us, everything is quite visual, and we should actually, harness this visuality and visualization technique to answer various questions. So let's learn the laws of vectorization. The first law of vectors is called the triangle law, and that is sufficient because its law is sufficient to prove anything else. So why this law? You may be asking why the vector follows the addition of law. So it is found that what is found that the Euclidean space. You know what is Euclidean space?
Geometrical.
Yeah. Okay, you can say the geometry as explained by Euclid. You can think that way also. So it is found that maybe you can say experimentally or intuitively that all the laws of vector generally follows the laws of plane geometry. Okay. So everything you know about geometry will be very much helpful here. So everything which you have learned about geometry that is going to be useful here also. So triangle law has come from of course geometry. So now, yeah. So what it says now, if I put into words, it's really lengthy. So learning is easy, but putting into words is lengthy. So I'll just put in words because I'm supposed to. Okay. So I'll just type. It's easy. So according to this law, if second vector starts from the tip of first vector tip of first vector, then the line joining the tail of first vector to the tip of second vector gives the taken in reverse sense gives the resultant. That's simple. Okay, so if you read this sentence, it's quite clumsy, like it's difficult in a way to understand, but it's very easy if you actually write it down. So what it is saying that let's say you begin with some vector. So you start with some vector and you're trying to find the resultant of the impact of two vectors. Maybe someone is experiencing two forces. So and the first force is acting this way, and let's say the second force or maybe the second vector is acting this way. So what you have done here is that you have drawn the second vector, keeping the origin or the tail of the second at the tip of the first. Okay. So now we are interested in finding the resultant. So what this law is saying that it's very easy. You start a line from the tail of the first and join the tip of the second. But you have to be careful here. You cannot join the otherwise, like you cannot join in the other reverse direction. It must be joined from the tail of the first to the tip of second, and the arrow of the third vector, that's called the resultant, will be in the reverse order. Now, what is the meaning of reverse order? So this vector is going this way, and just suddenly you start drawing this way. So you reverse the order. If I continue drawing like this, so these three vectors are said to be in the same order. So they have same sense of rotation. So what is important in the triangle law is drawing in the reverse order. That's very important. So now how we express these geometrical construct. So we start with some naming. So you may say that, let's say this is A. You may call this vector some name by B. These are just names, okay, because they are different direction. So they are different vectors. We cannot call by the same name. So what is the name of the pink vector? What we can say about this pink vector? Tell me what we can say. So we can say the pink vector is the resultant vector. So we call this as resultant vector. It means the effect that these two will produce and the effect that this pink will produce will be same. So the R is called the resultant or the total effect of A and B. Now in mathematics, we used to write the plus sign to add two things. But in vectors, when you write the plus sign, it's not addition, it's the language actually. So what does it mean is that R is the resultant of, now see, we are equating. It's nothing to do with the equality. So R is the resultant of A and B. So the plus should be read as and. This is not plus, it's called and. And when you equate, so you're trying to say, you're trying to communicate something in this language that R is being produced, this effect is being produced by the application of these two separate effects, A and B, and these two are equal in its effect. Okay. So R equals to A plus B means the two can produce the same effect as the R could have produced. Okay, that's the idea of writing vector equations. And you're not adding anything. Of course, you're not adding anything. You're just saying something. So you're saying that okay, R is equals to the resultant of A and B. Now, someone is let's say writing R equals to A minus B. Now in vector there is nothing called minus. It is again equivalent of A and negative of B. And what is negative of B, by the way? What is negative of
Acting
B?
in the opposite direction, or which is also known as
Correct, correct. So
unlike
a negative,
parallel.
correct. So it's unlike parallel. So negative of B is very much intuitive thing. So if I just reverse the direction of B, so the name of this vector is minus B. It's again nothing is negative. Vector is vector. It's having magnitude. It's having direction. So here the negative is the kind of nomenclature. Okay. So we are saying that this vector which we have produced is opposite of the B. And now if I ask you, what is the resultant of A and minus B? A, you can see A, in the diagram you can see A, and you can see also minus B. So what will be the resultant of A and minus B? Can you tell me the resultant? How I should draw the line to get the resultant of A and minus B? What I should have done?
So tip should be joined to minus
So
b vector.
correct. So I should start from where?
So from that orange line,
Yeah. So I should
a
start from the
vector,
Of the
yeah,
orange.
tail, and I should end the here the end of the B.
tip of
And
the
the arrow I should take this way, like which way? Like this is the arrow.
so towards b. Yes.
So the arrow should be in which direction?
So like
Towards me.
this only.
Correct. So we can name this as R dash. Okay. So we can name this as R dash. So now what R dash is representing here? It's representing the resultant of two vectors, namely A and whom? A and
Minus b.
minus B. So again, in vector, there's nothing called subtraction. You don't subtract anything. Okay. In vector, everything is addition. Okay. No, we are not drawing. This is a separate triangle. So if someone is asking what is this law, we are actually writing the triangle of for these two separate vectors, A and minus B. So let's say if I know how is B, then it's not difficult to draw minus B. So I wanted to show you the two triangle, like it's a addition of two vectors and the subtraction in the same diagram. That's why I have drawn like this. So the upper is, you can say, addition. So lower is like a subtraction, like a subtraction. I'm not saying it's subtraction. So intuitively, you may feel you're subtracting something, but in vector, there's nothing called subtraction. It's always all about the addition or the triangle law. So when you're writing the triangle law here, well, R dash is equals to A minus B. So if you go by the mathematical intuition, you may think this is subtraction. And I'm trying to explain here that there is nothing called subtraction. We have only one thing that's called addition. And for that to prove, what I'm saying is, you may think this as addition of A and the reverse of B vector. And because it's a new vector, because minus B is not same as B, right? So minus B is something different and B is different. So because minus B and B are different, so we have to, okay, either you can change the name, you can say that, okay, this is some vector C. So you can also write like the R prime is equals to A plus C. So again, it's a addition only. There is nothing called subtraction in vector. We just add. We don't subtract anything. Understood? So this is the triangle.
Sir,
Yes.
sir,
Go ahead.
did we draw the reverse direction, like the B inverse, sorry, B vector, A vector, and the resultant. Then the
Hmm.
head on head of resultant are resultant, and the B vector is just means they are connected to each other. And whereas A vector and B vector has their tail and head connected.
Okay, look at this. So the R prime is how much? A plus minus B. Look at this. Now, what is the triangle saying? You have to start from A, from the tip of the A. Okay, so you are here. Now you draw a minus B vector. So the minus B will be opposite to B, just reverse like this. So this is A, this is minus B. Okay. So A and minus B I have drawn. So what is the resultant of these two? The resultant of these two will be the line joining the tail of the first, as per the definition, to the tip of the second. Tail to tip. And that's why we are calling this R dash, because I have changed the name. But this is not the resultant of A and B, it's something else. It's A and minus B. So we have drawn it separately. So actually here, what you are looking is the two triangle law. Okay. One is for the addition, another is for the subtraction. But we are using the same vector in the reverse direction. So it's good to represent on the same graph so that you can realize that the B and minus B are reverse of each other. Okay. Is this clear? You have to only stick to the definition. You're not supposed to create your own definition. So whatever the definition says, you have to follow it. So what the triangle law says, if we have two vectors A and B, and if you want to find the resultant of the two vectors, what will you do? You will draw the first vector, and then from the tip of the first, you can draw the second vector. And then you may join the line from the tail of the first to the tip of the second in the reverse order, and that will give you the resultant. Now you may ask us, is it necessary that we must start with A? The answer is no. You can start with B as well, okay? And it will make no difference. So if you begin with B, still you will get the same answer. So instead of writing A plus B, you may write B plus A, because the addition is commutative. So that I'll prove later on in the parallelogram law, that the vector addition, you may write like A plus B, but you may also write as B plus A. That I'll prove later on. It's a bit difficult to understand why this is so. In mathematics, when you add numbers like 1 and 2, it really doesn't matter whether you write a 1 plus 2 or 2 plus 1. But in other mathematics, it's not always true. And that is why one must add in one particular sequence. You must maybe you will get some multiplication in which you cannot do the reverse, like you cannot write a cross b equals to b cross a. So the mathematics of vectors are quite different. Okay, so there are rules and they're obeying certain laws. So I'll prove this later on. This is called commutative law. So you may be thinking that what's the big deal about a plus b equals to b plus a, right? It's ridiculous. It's common sense or common. A plus b and b plus a are equal. Okay, but it is not. I mean, you will be surprised to know that it is not always true in vector algebra. Okay, in vector algebra, things are not always commutative. For example, I'll give you some simple example. You can understand. You can relate. So imagine there is a small kid. Okay, imagine there is a small kid, and you slap that kid. What will happen? If you slap the kid,
Can
what
you
will happen?
repeat?
The kid will start
Crying.
crying. Actually, correct. So now what you do is the next step you do, you bring lots of chocolate and the toys, maybe some dinosaurs, whatever he likes, and then you try to calm down. So probably there is a chance that he will calm down. Of course, you have not hit very hard, so you have just hit. So what you did, like there are two steps you followed. You first slap and then you gave some chocolates or toys. Okay. Now try to reverse the process, like do the two steps, but in the reverse order. So you first give chocolates and toys and then slap. What do you think? What will happen? Will he calm down? Will he remain quiet? Or he may throw all the toys and start crying? What do you think? The two steps taken in the different order will result in the same reaction or different reaction? What is the possibility? Tell me. So in both cases, the reaction will remain same, the end reaction, or you think that it may change?
So change.
Correct. So now what you can realize that the two steps, like the order of operation, when you change, you got the different result. Although the steps taken in both the case were the same. So I can say with this example that what we did was not commutative. So what we did was called non-commutative event. It's non-commutative event. But luckily, in case of vectors, the addition is commutative. It means whether you add A to B or you add B to A, it turns out to be same thing. Okay. So I'll prove this later. Don't worry. So how we could have drawn the B plus A? If I because it's the same thing, then how we could have drawn? So you can draw B first. Okay, so this is the B. Let's say this is B. Now from
So
the tip
can't B
of
be base?
the B is like this, no? This is the B.
So B can't be base.
How
So
can
but
be
if
base?
we don't want, if we
The B is B only. So A is A. You can't make it a base. Okay. So B is like this. So I have to draw like this. That's it. So we have A vector given like this and B vector given like this. So we cannot make it a base. It's like this only. So this is your B. Then how is the A? So A looks like horizontal kind of thing. So the A must be drawn from where? So A must be drawn from the tip of the B. This is your A, right? So now I have drawn B and I have drawn A. So how we expect the resultant? From the tail of the B
so tip towards B.
towards the A, tip of the A, and that's why this is the resultant. So what you can see that even if you reverse the process of addition, if you may begin with B and continue with the same addition process, the end result turns out to be same. So in space, the R in both cases will be similar. It's not going to be different. And that is why it is said that the addition of two vectors follows the commutative law. Now, this is the very crucial mathematical assumption about addition. And if someone will fail this assumption, or you can say this law, then they cannot be categorized as vectors. It is like for any physical quantity to become vector, they are bound to follow these laws which are already set. These are called mathematical axioms. Okay, so you cannot prove these things. Why this so? It is just like, okay, maybe some genius of mathematics, okay, they found this to be very intuitive, and they said, okay, it must be like this. Okay. And okay, from there they begin the theorems and all, and they were able to prove everything else. So these are called the axiomatic definitions of mathematics. The commutative law is one axiom actually. You can't prove this. You just, okay, believe that this is true. Okay. So the commutative law for vector addition is very crucial. Okay, for any vector to qualify as a vector. So if you follow triangle law, but beyond this, you have to also follow the commutative law. Okay, and the commutative law is the resultant or the product of parallelogram law. So I'll prove later on why it is called so. So I hope the triangle law is clear. It's not very difficult. Is this clear? Triangle law. What is triangle law? Two vectors are given to you, and you're trying to find the resultant. What will you do? You will begin with one of them. You will draw it the way it is without rotating and all. And then what you do next? You take the second vector from the tip of the first, and then you join the tip of the tail of the first to the tip of the second. And whatever you get in the reverse order is called the resultant of two. So here the R is the resultant of B and A. You can pay attention to what I'm saying when I'm writing plus sign. So how I'm reading? R is equals to B and A. So plus is like and. You're not saying it's equal or you're adding something. No, it's just a way of a representation. Nothing more, nothing less. All right. So oh, I may continue for some blackboard. Then I'll go to the whiteboard. So after this comes the next law. Which law?
Parallelogram law.
Yeah. Now these all are definitions. What is the parallelogram law? If you have heard before, maybe you can say something.
Sir, the diagonal of it is actually the resultant. If we
Yeah.
suppose the
If we have
we
two
have to
parallel
draw,
vectors,
sir,
then
if
the
there
Okay.
is a vector connecting to the head and head of it, then we can just draw the parallel verse of it, so that we can get a whole parallelogram.
Yeah.
Uh, and then the theta which the theta between the diagonal is the
Mhm.
theta we needed. Uh, and
Yes.
and sir, the r which is resultant is the diagonal of the
Correct.
uh,
Correct.
and its
Correct.
formula is
Oh,
r square equals to a square plus b square plus 2ab cos theta.
that's nice. You know a lot of things about vectors. That's really good. So now, what is the parallelogram law, and what it says? It says something very simple, and you may say see this as an extension of the triangle law. So it's nothing new actually. So it's just an extension of the triangle law. What it says that if you take the two vectors as two adjacent sides of a parallelogram as a co-initial vector, like there's some rules, to take the vectors the way it should be taken. So what I'm saying is you have to take two vectors as a two adjacent sides of a parallelogram. So let's say this is my A. I'll just change the color and make it bigger. And let's say this is B. So that it looks like a parallelogram. And you have to take this as a co-initial vector. You can't take the way you want. You can't take any random way. Okay. So what we have done is we have taken this as co-initial vector. So now this is the origin. This is called the origin of the two vectors. They have the same origin. This is A, this is B. So we begin with the two adjacent sides. And now this is the called the angle between the vectors. You can set it. Okay, that's a different story. Now what you do, you draw two vectors parallel to each. Okay, so you can slide the vector. So you or you may draw separate vectors. So you draw two vectors which are parallel to each other. Now we know the property of parallelogram. So if this is B, and because the other vector which I have drawn is equals to length that of the B and having same direction, so basically these two represent the same vector. So I can say B. And if I draw a vector parallel to A, because it's a parallel means same direction and same length as well, so this is called A vector. So now if you take two vectors as the two adjacent sides of a parallelogram as a co-initial vector, then the diagonal is starting from the common origin. I can't take any diagonal. You can't take this diagonal. So the diagonal is starting from the common origin will give you the resultant of the two vector. That's the definition. It's a very lengthy in word, very wordy. So the resultant of the two vector will be this line. This is your result. Okay. So let's put in words. What we can say? If we take two vectors as the two adjacent sides of a parallelogram, then the diagonal is starting from the common origin of the two vectors gives their, you can say, gives their resultant. Okay. So that's a okay definition. And now you can realize something very interesting. So let's invoke the triangle law. And I can also say this triangle as alpha. Let's invoke the triangle law in the lower triangle. Can you see this triangle? And according to this triangle, if you look carefully, if you apply the triangle law, what you can say, R is equals to how much? If you look at the lower triangle, so if you look at the lower triangle, the R is how much? It's a B plus A.
B plus A. So we always take base first.
Yeah,
Yeah.
you start with one. So if you start with A, then how will you reach the? So you will always start with the tail of the vector. So the R begins at B, right?
Yes.
Where the R begins? Can you see where the R begins? It starts at B, isn't it? Now this is a lower triangle. What about the upper triangle? Maybe I can suggest triangle. What about the upper triangle? So where you begin?
Also A plus B.
Yeah. So you begin with A actually, and then you end up B. And therefore you can see that we are getting two answers for R, A plus B and B plus A. And that's why, oh, that's why they are commutative, because that's why how I have proved. I have proved using the triangle law. I took a triangle as a maybe some axiom and I believe that triangle law is always true, and therefore I apply the triangle law in this case, and then I prove that it's a commutative. So now I have proved that a plus b is same as b plus a. And now this brings something very interesting concept here. If you recall your first lecture of unit and dimension, if you can recall, I mean, that's the difficult part. So if you can recall the first lecture of unit and dimension, and if you go back to the definition of vectors, like what are the vectors, what are the
Yeah,
scalars?
scalar rank 1.
Yeah, so I did mention something called the finite angles are
Yes, sir.
scalars.
And elementary angles are vectors.
Yeah, that's very crucial part. So okay, this is not a vector. So this is, so theta are scalars and d theta are vectors. So why elementary angles becomes vector? That is what we are trying to prove here. So the big angles are scalars, but the small angles are vectors. That's something mind blowing. Let's see why. So to understand this fact, we have to use the commutative law. So for that, I need to do one demonstration, and for this demonstration, probably you all can perform at the same time. So let's do one thing. Okay, let's hold your notebook in your hands. Just do this, everyone, and probably you all can switch on your video so that I can see and I can say something. Okay. So I need to see your videos. Please be well dressed. Okay, if you want to switch on your videos. Okay. So just hold your notebook and switch on your video so that I can guide you what to do next. Yes, everyone. You guys can start your videos.
Hello, sir. Too much. I'm noting, sir.
Okay. Okay. Now I'm saying that okay, you can switch on your video so that I can start the demonstration.
Sir, done.
Okay. So switch on your videos. Are you guys listening what I'm saying? Hello everyone. Hello 1 2 3 1 2 3. Okay, Harshit is live. One more, at least Atharv, you can come. Okay, fine. So now you show a book, you are holding in your hand. So make sure that there is a book in your hand. Yeah, just put you hold with both hands. Keep it in front of you. Just close it. Don't open. Close it. Close it. Yeah, just hold it. Like, just put it in front of yourself. Yeah, just the way you show it. Yeah, just like that. Yeah, the way Atharv is holding. Yeah, that's correct. Okay, so now what you will do is you will give your book rotation. So I'll tell you you have to rotate by 90 degree, but two times. So you can choose two 90-degree rotation. So maybe I can show something like this. Yeah, you can choose two rotations the way you want, but make sure you remember the rotation. So maybe you can rotate like this. You can rotate like this, or yeah, just rotate two times. One down, one down, one down, one down, first down, yeah, first down, then left, then left,
Then in this way and this way.
yeah, only with 90 degree, yeah, one down, like yeah, you hold it vertical, then one down, 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 make it horizontal, down, 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 yeah, like this, yeah, correct. The Hershey's is doing that. One down, yeah, make it horizontal, yes, yes, yes. Just wait, and now turn 90 degree left, or anti-clockwise? 90-degree anti-clockwise from your front view. Okay. Probably I need to show. Okay, so maybe I need to start the videos, but I'm looking very bad. If you look me, you may get scared also. Okay, anyway, I have to do this. Okay, so I hope you guys can see me. Probably. So don't be scared. Okay, I'm like this one. Okay, maybe I take my favorite book. Okay, so you can see this is my book, Problems in General Physics by Erodov. You can see this. And what next? You are supposed to rotate by 2 rotations. So I am rotating 1 like this by 90-degree. And then I'll turn like this. Now you can see this is my book. After 2 rotation, this is the orientation of my book. So first one, second. So I hope you remember the rotation. 1, 2. So the first is down and second is the anti-clockwise. And this is the eventual orientation of my book. Okay, I hope you can understand. Now let's do the reverse process. First anti-clockwise and then down. So what do you realize? Is it same orientation or different?
Different.
So now I have given the 2 rotations, but I have reversed the order and I end up getting the different answer. What does it mean? I have rotated twice, okay, but in
Direction
different
and
orders.
x.
And the final orientation of this book turns out to be different, same or different?
Different.
Different. Which means it is not following the commutative law. And that is why the theta is put under the category of scalar. That's the reason behind the scalar classification. Now try to deal with this, the second variable d theta. So what I will do, I will turn slightly, very small. So probably you can't see it. That's it, like this. You may have seen something like this, very small. So down and maybe anti-clockwise like this. Okay, this is my book. Now you can see my book. So down, turn. That's simple. Down, turn. Can you see my book? Yeah, I hope so. Now let's reverse it. First you rotate and then down. Yeah, it's same. Once again, down, rotate. Can you see my book? No. Rotate, down. No, it's same. Now what we can see, and I hope you have understood this part. So now what we can see that this elementary angles are following the commutative law. So we can say this follows commutative law of vector addition. So now again, it's one of the axiom of vector algebra that if you are using the addition, then it must be following the commutative law. And if it is not following the commutative law, it cannot be called a vector. So this parallelogram law helped us in understanding that the vector addition is bound to be commutative. So any vector which is not following this particular law will not be called vectors. And now this is a very crucial example that we need in the chapter of rotational dynamics. So elementary angles are vector quantities, whereas the big angles, or you can say the finite angles, are scalars. Okay. So now comes the last law. So let me end this law, the law today.
So please will you show the previous screen, please?
Yeah, that's true. Okay, I should have mentioned this here also. This doesn't follow the commutative law.
The electric strength and pressure also
Yeah,
follows
they do not follow
commutative
the,
law.
yeah, they fail to follow the triangle law. And of course, because they fail the triangle law, so they never follow the commutative law.
Sir, area.
Pardon? Yeah, tell me. Are you saying something?
Sir, area is vector scalar.
Yeah, area follows. Yeah, the
Yeah,
elementary area, not area. In fact, you can say again, elementary area are vectors. Okay, but the big areas may or may not be vector. So elementary areas are vector. So dA is a vector always.
Sir, can you tell what is like elementary exactly?
Okay, elementary means if I ask you which number comes after zero, what will you say? Tell me the number next to zero.
Sir, but integer या फिर any?
No, I'm just saying number, any real number.
0.00000 continuous and then 1.
But it means the simple idea is you can't say. That's a better way of saying.
infinity.
And you can't say actually. Say the idea is what is number next to zero. There is no way to express.
Undefined.
Yeah, actually it's undefined. Okay. So a number next to zero, we don't know which number comes exactly after zero. But what we know that there is a number next to zero. That we know actually. So a number next to zero is called limiting value. And in mathematics, to deal with such scenario, we develop the calculus. That's the very idea which we started with in calculus. That limit is something we define for that scenario. So when you say limit x tends to zero, so you're trying to say this x is as close to zero as possible, but not zero. So maybe this is the number next to zero. So I can say this is the number next to zero. It's a way of writing. I mean, you don't say it. It's a way to understand. So elementary means something which is like the first area, and you increment this area by some value. So the value which is next to a plus something, like something is how to write something. That's very difficult. So Newton said, okay, don't worry. You can write this something by this symbol dA. So what he said that if you make the infinitesimally small increment, then you can represent like dA in area. So whatever a physical quantity or any quantity you may take, so let's say you take some random quantity sign, okay, you can take. And if you add d before it, it is the smallest change in this possible. So d means change because d has come from the delta. Delta represents change. This also represents change called del. Now this is called delta. Now this is very interesting story. Delta, but we say this as del, and then comes the, okay, this is change, not charge. Then comes the d. This is also change, and we call this as d. Delta del d. Just name. So this is the big change. This is slightly complex. It's called partial change, and it's called the exact change, the elementary change, the smallest possible change we can have. That's the idea. Like I don't know what is the dA, but this is the way to write the intuition that this is the smallest possible change in A. That's it, or change in any quantities. So when you write dx, it means the smallest possible change in x. So when you add dy, the same thing, the smallest possible change in y. Dt is smallest possible change in time. So all these things we can represent as limiting values. So limit the change approaching zero, but not zero. This is same as writing limit delta y tending to zero, and that's you can add this as limit delta t tends to zero. So this is a cumbersome expression, right? Writing this way is cumbersome. So Newton devised a better, looking nice looking expression for the same. They represent same thing, but what you want to deal with is up to you. That's why we have two principles called the first principle in calculus to solve the differentiation, if you remember, and then we have the operator concept. Okay, so we have introduced this already, and I should not revisit this thing again. So you can go and watch those videos and lectures to understand more. So what is elementary? Elementary is something and it's the nearest value, which could be possible. Okay, abstractly, it's abstract notion.
So then the Earth moves to 15 degree at each hour. So in 1 second there is a difference of d theta, right? In 1 second.
Yeah, you can say in 1 second it's a really d theta. It's very small. So d theta is just a concept. You cannot actually realize it. You can just understand. Okay, it's like the notion you begin with and then you do something. Okay. Computationally, if we talk computationally, how the computer will implement the differentiation or integration. So they make the interval as small as possible because we can actually go up to the maybe some thousands or maybe billions points of decimal, like computer having this power. So we can achieve the degree of accuracy by such assumptions. Okay, but there is nothing called absolute or exact answer. So we only have the notion of accuracy. There's nothing called absolute answer. Like the value of pi is known, but not exactly known. So you may say 3.1415 and so on, so on, so on. You may say 100 decimal place, but that is still going forward. It's not ending there. So the idea is everything is in continuation. There is nothing like absolute answer. So pi is something called a value we are trying to reach, but we haven't reached yet. So pi is still pi. And because I need to write it in a simple way, some nice looking way, so we have devised a symbol for it. So pi is not known. Pi is still unknown, but pi we have known to a degree of accuracy. So there is a lot of theorem about pi. Okay. So we have something very nice theorem called basis functions and all. Anything. So pi is a huge thing. Now no one is interested in pi much. So we need pi, of course, for the satellite motion, for the interplanetary motion and all. We need more and more accurate value of pi. And now you may be asking why. Okay. So okay, leave it. It's a big story altogether. The idea is these laws are set forward. Okay, set forth you can say, maybe as an intuition to some mathematician, and you are supposed to follow it. So don't try to question these laws. Okay, if you question these laws, maybe you will become no law. Right? So it's not bad. In fact, you can question actually, and you will end up becoming something really great, of all time. So you will become a goat, greatest of all time. You will not become Bakri, you will become goat. That's a really nice abbreviation. Let's begin the last law, and that's called the polygon law. Now, this law is again the extension of triangle law itself. So, what this law says? It says that if you have more than two vectors, maybe three, four, or maybe 3,000. So, if you have more than two vectors or any number of vectors, and if you keep on drawing the other vector from the tip of the previous vector, then the line closing the polygon and beginning from the tail of the very first to the end of the tip of the last vector gives the resultant. That's very much intuitive. It's not difficult. So you start with some vector.
Sir, ऊपर why have you written greatest of all time?
My bad. Okay, I remove this now. So now let's say we have multiple vectors. And if you keep on drawing from the tail of the first to the tip of the second and so on and so on, then the law says that the line which closes the polygon. So to close this, I have to draw something like this. So let me close this polygon. So the line which I'm drawing is closing the polygon. And this will give you the resultant of all these vectors. So I can name it as A1, A2, A3, and maybe I should have continued to A4. Let's end it. So the R will be equal to how much? So R here is representing the resultant of A1 and A2 and A3 and A4. So how we can prove this? This is pretty easy. So to prove this, you can first complete
So
the
this
triangle.
follows for any solid shape.
You know, any shape. It is having no shape of.
So like
It is not even. I'm not saying it's a regular polygon. I'm saying just saying polygon. I'm not saying a regular polygon. So it could be any shape, any size. It could be in any plane also. So even I'm not restricting the plane. I'm saying it could be in any plane. Triangles law always represent a plane because with two vectors you can't have a three dimension. You can have only plane. But
sir,
when
one
we have
question.
other,
So I have one doubt. Sir, if
yeah,
it's a solid shape like hexagon or like that, sir, so will there be any vector because the end point and
yeah,
the tip of
yeah,
the
that's
last will be joined.
yeah, that's a really nice. That's a really nice question actually. So I will answer this question. So what you are saying is if the beginning and the end will coincide, that's you are saying, right? So
Yes.
if the end vector, the last tip and the first tail coincide, so of course the R will shrink to zero. So any closed polygon in order represents zero resultant. So when you draw any closed polygon of any size, and if all arrows are vectors, like there is no end, I mean I'm putting everything in the order. So you can see the last vector is matching the first vector.
Sir,
If-
except
if-
triangle and polygon, triangle and
no,
quadrilateral,
no,
right?
no, no, no. In fact, triangle also you can draw like this. See, I have no choice but to think that okay, the end vector at the beginning is again matching, isn't it? Everything you can start from anywhere, not only this dot. You can start from anywhere. If the arrows are all are in the same order, so these represent the closed shape, and this means the beginning and end are same, and therefore you cannot draw the resultant, or you may imagine that R will shrink to zero. So these all closed polygon in which the arrows are in the same order. This all represent zero resultant. That's a really nice concept. Anyway, so this concept anyway, I mean, we were supposed to know, but it's not zero. It's zero vector. We say null vector. So all R will be null vector. Okay, don't say zero. Zero is a number, scalar, but we are writing vector. So any closed polygon where the beginning and the end, here you can see the beginning and end are not same. And this is the end. This is the starting point. The start. and there is a gap between the start and end. So there is a result. Now, if I draw multiple lines like this, you can think triangle or you can answer this. So what is the first triangle? A1, A2. This will be how much? A1 and A2. Now look at the second triangle. The A1, A2 is one side, A3 is the other side. So what is this value? 1 plus 2 plus 3. And then again look at the triangle. So the R will be this much. So if we keep on drawing the triangles in each polygon, eventually we end up getting the resultant. Okay, and that's simple. Is this clear?
Yes, sir.
Okay. Okay. I'll show you why this is zero. I'll just prove it. Don't worry. Imagine uh, okay, let me have a green board now. Let's see if it is better. No, it's not. Maybe dark green is. Yeah, this replicates the green board, and I will use the white chalk. And the white chalk is better. So look at this. Why the closed polygon gives you zero resultant? You can think this way. 1, 2. So let's call this as A, this as B, and this as C. Now this is counterintuitive. You're not able to think of triangle on there. That's yeah. You can say that I'm not comfortable with this triangle. So you do one thing. You just draw once again. Make- make. So this vector. Uh, and pay attention here. What I'm doing. So what I'll do is I'll just change the arrow of the C vector and I will name it minus C because we know that C and minus C are just opposite of each other. So if this is called C vector, I can say this as minus C vector. I hope there is no problem. And you can realize that, what you can realize? That this is the resultant of these two as per triangle law, isn't it? The third vector is in the reverse order. So this must be representing the resultant of A and B. Do you realize this fact? Yes or no? So can we write minus C is nothing but A plus B? That's triangle law. So can we write like this? Yes or no?
Yes, sir.
And therefore, can we write A plus B, bring C on the same side? And therefore, all the three vectors adding up to 0. So that proving that the vectors resultant is 0. So the three vectors, when they add up to 0, it means it forms a closed polygon. That is what I'm saying. So whenever we have n vectors, for n vectors, maybe you can name it A1, A2. If they add up to 0, then it forms a closed polygon of n sides. that's the idea of whenever we have any number of vectors, and if they add up to 0, it means they are always forming the closed polygon. So for 3 case it's triangle, for 4 it's 4 it's square, yeah, maybe infinite. Okay, 5 it's something, then 6 something, 7 something, something like this. Yeah, someone want to say something?
Sir, but in the first diagram, sir, it is wrong, no?
Pardon?
Uh, sir, the tip is, sir, two tips made first, no?
In the first diagram, the last vector coincides with the tail of the first. So it means there is no gap between the two vectors, right? The beginning and the end are at the same point. So R is 0 because R is not there.
Ah, sir.
So see, this is the R value. This is your R, and you can see that R is 0 because R is the sum of all vectors, and that is 0 answer. So the polygon is simple, like the closing side will give you the resultant, and if there is no closing side which you can draw, it means the resultant is 0. You can always say that. If there is no closing side, then the resultant is 0. So this is the all the laws which we needed to know. We know every law of vector addition. We have proved is a very important identity that's called the commutative law. So the vector addition must follow the commutative law property. If they fail to follow, it means they are not vectors actually. So commutative law is like the rule book of vector addition, and you must abide by those rules. So now we are going to calculate the resultant.
Sir, I want to see the last page.
This is simple. So I can draw this like something like this, maybe. Then many vectors, then
Sir, if there are infinite number of vectors, and if it is closed, then it is a circle, sir, right?
uh, if it is infinite number of vectors, then why it should be circle? Then
Sir, like if they are evenly they are regular polygons, and
yeah,
if there are n,
then what you're saying is correct. Yeah, you have to mention that it's for regular polygon. When the angle between the two consecutive vectors remains the same, and if the number is really infinite and it's a closed loop, so definitely what you're saying is absolutely correct. It's a circle. Circle is basically an approximation to the infinite polygon. Of course, the regular polygon. Okay, so that's true. That's correct. In general, we can't see. So let's go next.
sir, do we have any law for it?
For what?
Circles.
Circle is not a law. Circle is the approximation of, you can say, if we have a regular polygon and if the each side of the polygon is equal in length, they are equal in length because it's a regular polygon, so they have same side length and same angle between the two consecutive vectors. So in such case, the shape will tend to the area like a circle, and in fact, you can prove the area of circle using polygon also. So we can prove the area of circle as polygon. Yeah, that's true. Anyway, so let's come to the now what we are looking for. We have understood the laws of addition. So maybe triangle law or parallelogram law or maybe uh, the polygon law. It's depending on number of vectors we deal with. So we want to find the magnitude and direction. That's our intention. How to find the magnitude and direction. So to find the magnitude and direction of a resultant, you can choose any law. So the best is triangle law, or you may choose the parallelogram law. So we find the resultant of two vectors at once, and therefore we should use either triangle or the parallelogram law. Okay, only two at once. You can't take three, four at once and find the answer. Yeah, once you have the answer for the two, then you can continue with that answer and the next, and then you can find the next answer. All right, so we have two vectors A and B. And when we represent something graphically like this, then it will have length A, or if you are not, okay, this is a better way actually, but you can also represent like this. In advanced mathematics, we represent like this. That's not required. And then this B we can attach just B, it's called magnitude. So if you write it just without arrow, it is the length of the vector. So you can also think this is a geometrical construct, and each line which I have drawn is representing its proportional magnitude. So what we are supposed to find when it comes to magnitude is the length. So at the end of all this discussion, we are only looking for length, nothing more, nothing less. So we have no other intention. So we just want this green length. What is the length of this green line? That's my magnitude of resultant. But what we need to know further. So we need to know the angle between the two vectors. Because unless we will not fix this angle, the R will not get fixed. Because if you rotate the yellow line, you can imagine that you're turning the yellow line, and you can see R will change. In fact, you can animate. You can animate mentally. So let's say if I draw something like this, keeping the tip of the tail of the B as center, you can realize something very nice. So let's say this is the center. Okay, center of the circle. And if you rotate the B vector, so B will turn maybe like this. I can draw B here. So we can go here also. We can go here also. Okay, we can go here also. So in fact, we can draw mini B. Yeah, we can be like this also. So as you change the B, what you can see, how the R will change. Can you realize how R will change? So probably you can show the R like this for this vector this way. If B is here, this is R. This could be the R.
Sir, A is fixed.
Yeah, A is fixed. I'm just see. I can change the orientation of the other vector with respect to the first vector, right? Why I will change the? Okay, I'm not changing the length. Come on, I'm only changing the theta. That's I'm
So
trying to
no, I
demonstrate.
am saying the position of A is fixed or not.
Yeah, yeah. You have to keep one as fixed and then change the other. That's it. Now, do you realize that R is variable if theta is variable?
Yes.
It means if the angle between the two vectors will change, it will end up getting you different resultant. And you can also realize that where you will get the smallest R, smallest resultant when you are here, because that is the only R. This is the R, and the biggest R will be when the yellow line is here. Then this is the biggest resultant, the biggest value of R. Okay, and in between you will get many other values. So the idea is resultant of two vectors depends on not only magnitude but also how they are oriented with respect to each other, called the relative orientation. Let me remember this. I don't know this. Okay, so now we are back to the original problem. So theta is a very crucial part in finding the resultant, as theta will vary. So the length of the third line. So resultant of two vector depends on A length, B length, and their relative orientation. So the three things will decide the length of R. That is what we need to be careful about. So what we can write here? So we are looking for the length. So what we'll do is we'll just remove the arrow and all. We are not interested in arrow no more. We don't need even in fact these arrows. We just draw the triangle and think of the length. So magnitude of two vector is nothing but the length of the resultant. Length is the word for magnitude. In fact, later on it's called length only. So this side is having length here, this side is having length B. This side you want to find the length because you have no idea. You can say R. And what else is given is this angle. Now in mathematics, the only law which we know is the Pythagoras. And that is the basis of all derivation. Because at the end of the day, we can convert every triangle into right angle triangle. That's the power of Pythagoras. So Pythagoras is like one of the most fundamental construct in mathematics. Then how he came to know about this fact, that's something very interesting. So in order to convert this into a right angle triangle is the only choice that I'm left with, because the only law I know so far is the Pythagoras, and from there I am going to have the other complex laws. So let's say I'm dropping a perpendicular from this vector to the base, and we can use the trigonometric formulas to get the length of the part here. I can say this is x, this is y. So what is x here? Can you tell me what is x? X is how much in terms of b and theta? What is the angle, the value of x if you look at this triangle? So you can tell me what is x, because you know
So B cos theta.
yeah, that's correct. And similarly, you can say what is y?
So B sin theta.
That's absolutely correct. So now we are ready to good to go, because what we were looking for is the length of the base and the height, because the only thing we know is Pythagoras. So I know now the base, which is a plus x. Now this is pretty easy to understand. So this is a plus x, and this is y. And now we can apply the Pythagoras to get r, because that is what we are looking for, the length of the resultant. So what is r now? So r is square equals to a plus x whole square plus y square. This is how we begin any derivation, because the only thing we know is the Pythagoras, and therefore we have to proceed from Pythagoras to the other complex situation. So the r square is how much? A plus x whole square plus y square. And therefore, I will just substitute the value of x that we just obtained, which is b cos theta. And y itself is b sin theta. And now we can expand. Okay, what I'll do, I'll add somewhere. I don't have space here. Shift. Now we have space. So what we can write next is just expand this a square plus 2ab cos theta plus b square cos square theta plus b square sin square theta. All right, so we can add a square plus, okay, just rearrange this part. So we can add this part as b square into sin square theta plus cos square theta plus 2ab cos theta. And we know this is 1. A is to sin square plus cos square. So now using the Pythagoras, we are able to find the third length, the length which was unknown. And that's called the magnitude of resultant. Because length is magnitude, that's simple. So A, B are the length of the two vectors, then the length of the resultant is. Now don't mug up this formula. Rather, I will say try to realize the formula. Well, maybe this is one derivation, but you're not supposed to mug up at all. Like, you can always do the Pythagoras and get the answer. In fact, I will encourage to do more of the when you're solving the question, just construct the triangle and then try to see the answer. So that will give you some extra advantage in terms of solving ability of numerical questions. Okay. Now here we need to realize something, that when we write in this formula called R equals to whatever, here theta is very important factor. What is theta representing here? It's not some just formula. Theta is the angle between vectors. Theta is so sometimes they are also looking for what is the angle between the resultant and A. So because the resultant is this way, okay, I should have shown on the other one. Because the R is this way and the A is this way, so this is the angle between R and A. I can say this is alpha, because now sometimes they ask alpha also. And finding alpha is pretty easy in this triangle because it's a right angle triangle. So what is tan alpha? Can you guys tell me what is tan alpha?
So can you repeat?
Now I'm looking for finding this value alpha. Alpha is the angle between the resultant and A vector. So in
So
how
B
many
sin
ways?
theta upon
Yeah. So
1.
I'm looking for alpha angle. So in how many ways I can find alpha?
Sir, inverse trigonometric functions.
Yeah, exactly. In all trigonometric functions, you can express the answer alpha. So you can express as sine, cos, tan, cot, whatever you want. So let's express in the first three. Sine
So
alpha.
one doubt.
Yeah.
Here theta is represent that what you showed in the diagram, that only, no?
Yeah, exactly. This theta is
Or
same like
180 minus theta, that angle.
pardon?
So not the angle inside the triangle, no?
No, it's not inside and outside. It's the angle between the vectors. And how we find the angle between the vectors that we have done in the maybe previous lectures. So to find the if you are who are you? Like, I think, what's your name?
Sir, I am telling that.
Yeah.
So can I show in the screen?
Yes.
Yes.
Okay. So why you want to take that angle?
Sir, I thought that angle was to be taken. That's why.
Okay. So how you find the angle between two vectors? What you do to get the angle? What is the angle between two vectors? How we get it?
Has a tail to tail.
Tail to tail.
Right. So when you join tail to tail, what do you expect? Theta or a pi minus theta?
So theta.
Exactly. So it has nothing to do with the triangle we draw. It has to do with the angle which is already there. So we have to learn from there. Okay. So now if I am trying to write sine alpha, I can write in the lower triangle. You can look at the lower triangle. And sine alpha is pretty easy. It's a opposite y upon r. And the y we know is b. So alpha we can write as sine inverse of this value. But that's fine. But if I try to express in terms of cos, yeah, that's quite possible. So what is cos then? Cos alpha will be a plus x by r. Okay, that's fine. So a plus b cos theta by r. I'm not writing the formula of r. But in these two calculations, we need to know the r. So that's why we don't prefer. But sometimes it's also useful. So let's write the last one. The last one is tan. And it's easy, y by a plus x. There's a b sin theta. Okay, so these are the ways in which you can express the alpha, tan, sine, cos, and in fact, there's no restriction on which one to use. But preferably, you will see that the answers are mostly represented in terms of tan, and the reason is it does not need r calculation. But if you use the first two, then you need to first calculate the r, and then you can proceed from there. So
So in second one there is cos inverse, no?
yeah, of course, it's cos inverse, the tan inverse. Okay, okay. In fact, I should put actually. Yeah. So the alpha here you can write as cos inverse of, and similarly tan inverse. So again, I will request to all of you that don't take this as formulas. Like these are not formulas which we have derived and all, and you're supposed to mug up the formula. Rather, try to understand that at the end of the day, it's just a triangle, and you're trying to find the length. So it's nothing to do with the vectors. Although the notion is started with the vector, but what we are doing is nothing to do with the vector. Like we know how to do the trigonometry in triangle and square and rectangle. So we know all these things. So I will not say that you mug up the formula, because generally, if you start doing mugging the things, then solving tough question becomes very difficult. So
So
try to
Ganesh,
realize.
from
That
previous
is your last screen.
Okay. I hope this is done.
Yes, sir.
So little related to later end part.
Okay. Can I move to the next screen if it is done?
Yes, sir, done.
Okay. So now look at this. If I ask you, let's say what is given to you. First, you understand what is given to you. Let theta be the angle between A and B vector. Find the resultant. Find the magnitude of resultant. Find the magnitude of. Okay, I will mention length. Graphically, it's length. So find the magnitude of resultant of A minus B. Now I'm asking different question. So you know the formula, maybe you know the formula, but what I'm asking is, what is the resultant of A and minus B? That's the question I'm asking, because A minus B refers to A and minus B vector. So what you will do? You will draw the diagram of A and B first, just some random diagram, and then you will draw the A and minus B diagram, and then you will tell me what is the resultant value. So okay, let me do this first.
So
Or if
we'll
you want
try.
to try,
So
okay, okay, fine, you can try. Can someone do from basic? Like I'm not saying without using any formula. Like the Pythagoras is the basic. and you have to start with Pythagoras and then try
Yes,
to
sir.
understand what, because that will develop your intuition what goes behind the scene. Like the formula is something, okay, we all I don't love at all any formula. I always go from basic, and then yeah, formula is a part of practice. It becomes natural after some time. That's okay, but don't only rely on the formula. What if you don't remember the formula at all? Then Pythagoras will help. And so I want you to practice your Pythagoras. It's not about vector or derivation.
Sir, I got R square is equal to A square plus B square minus 2AB uh, cos. No,
Cos
sorry, not cos. It will be 180 minus theta. So it will be, yeah, cos theta, 2AB cos theta.
that. Yeah, so the length of this vector, the new resultant is under root of a square plus b square minus 2ab cos theta, right?
Yeah, sir.
Yeah, that's correct answer. So you did it with the Pythagoras or by the formula?
So Pythagoras. So first what
Very
I took, first what uh, means I assume that there is a B vector and a A vector which is
good.
joint from tail
Yes,
to tail. So I have to convert it to like, so I took its direction to means I changed the direction and I got minus B vector which is joined with
correct.
A vector
Mhm.
uh,
Correct.
in reverse direction. So then
Correct.
I elaborated the A vector line and B vector
Mhm.
and formed the right angle triangle. Uh,
Mhm.
then I got the minus b vector that by the Pythagoras theorem. And
Mhm.
afterwards, sir, I had put minus b vector formula and a
Mhm.
vector and means by the Pythagoras theorem, I did it like
Yes.
r square equals to by in the bigger right angle triangle, r square
Yes.
equals to a square plus x square, which is the distance between that, and x square is nothing but it is nothing but the b b cos theta.
First.
So
Correct.
afterward, and in the place of the b, it is actually minus b. So by
No, no, no.
squaring it,
Then you got wrong. See, minus b is the name of the vector. The length is still b only. So lengthwise, it's not negative. Length is always b. So the magnitude represents just length. It has nothing to do with a minus or plus. Length is length. Okay. So you're supposed to only think of length. A and B are
yeah, sir, it
these
is
are,
and minus b, right?
yeah. So minus B is something name of the vector, which is reverse of the plus B. So if you try to do from basic, so let's me do the
So I
usual.
also got the answer. I didn't write
How
my
much you
mind.
got?
How much you got? Sir, is under root a square plus b square minus 2ab cos theta.
That's correct. That's correct. I think all are
And
getting the right
okay.
answer. Just I need to confirm the method. Like, are you following the right method? So this was the old R. So now this is I'm not looking for. So, still, I will just draw this for the sake of completeness. So this was the old length we were looking for, and we got it. In fact, because we chose the angle between the vectors A and B, this is the angle between A and B. and this length was A, this length was B, and we did all thing to get done. So now minus B is a new vector. So minus B is a vector which is opposite of B. So okay, which color I should choose? Yeah. So this is a minus B because this is exactly same in length. It's not different. And now you want to find this length. That is the idea. See, you're looking for this length. Remember, the magnitude is just length, and length we are trying to find. This is the length. So I want the what is the orange length of this triangle? That's something simple. I can say r dash as
Sir,
a
I did the same.
yeah. So
Yeah,
this is
sir.
theta. This is theta. That's simple. And this is b only. The length is b. So if I draw a perpendicular from here, this is my the right angle triangle of this side. This is the right angle triangle. I'm looking for this triangle, and for this triangle, we know this is b cos theta. In the lower triangle, if you look at the lower triangle, this is b cos theta, and this is b sin theta. But what we are looking for is OA. What is OA here? Not this one. This. Let me name it.
A call from +912268984853.
So let's name it A. Just a minute.
A call.
Okay. So now let's say call this as A point. This has maybe some point B. Yeah, correct. A minus B cos theta. So the OA becomes A minus B cos theta. And now finding the Pythagoras is so R dash is how much? Maybe square is how much? It's A minus B cos theta whole square plus B sin theta whole square. And of course, if you rearrange and all, you get the answer. And because length is always positive, so we cannot try to put a minus sign here. So we just add plus sign. Because what we are finding is the length. Okay. So the way of writing these things, like there is a very nice way of putting this thing. That if we write mod of A plus B, which means the resultant of A and B, length of resultant of A and B equals to A square plus B square plus 2AB cos theta. Where theta is the angle between A and B. Theta is angle between A and B. So what is the modulus of A minus B? What is the length of the vector A minus B? So that it turns out to be A square B square. Now what is interesting here? In the calculation of this A minus B, I have taken the angle of the previous condition, previous case. So the theta here is same. That's why the answer is different. Okay. So here theta is still the angle between A and B. It's not A and minus B.
So because it is vertically opposite.
Pardon?
So because it is vertically opposite.
No.
The
Because we have,
vertically opposite angles, right?
no, it's not vertical. See, in vectors, if I ask you what is the angle between A and minus B, can you tell me the angle between A and minus B?
Same as and
No. No. Okay, one second.
180 minus theta.
Yeah, that's the right answer. The A and minus B, that's very crucial thing to understand. The moment I describe, okay, I'll do it on a separate graph because this will make it very much messy. This is very important, and I think this is the part which you still missed. The entire practice, like this entire exercise, was meant for this one. So when you reverse a vector, and if you know the angle between the two vectors, already. So let's say the angle between the vector A and B, let's call it theta. So the angle between A and B, we have to represent on the right hand side, the tail to tail thing. We have done this. So the minus B is here. So what is the angle between A and minus B? Can you see the angle between A and minus B? Is this the angle between A and minus B? Yes or no?
Yes, sir.
Yes,
No.
sir.
What is the meaning of angle between two vectors? How we find the angle between two vectors?
Sorry,
So
sir. It
not
will
that
be
one,
180
minus
minus
B and
theta.
yellow line. So between.
Yeah. So either you join tail to tail or you join head to head, but what you are saying is wrong. No? Therefore, the angle between A vector, which is towards the right, and B vector, which is down, slightly slant and down, the angle between the A and minus B is this angle, which is pi minus theta. So if someone will ask you what is the angle between vectors A and minus B, the answer is pi minus theta. So if you go by the formula A minus B, imagine the first formula is true for given angle. So how we can use the first formula to get the second answer? Square of the length of first, square of the length of second plus 2ab. And what we write here? Cos of
180
angle
minus theta.
between these two vectors. And you know this fact that cos of
Minus cos theta.
that
Sir, I
is
also
why,
did the same thing.
yeah. So that is why if you want to use the first formula, you need to realize that if I know the angle between A and B as theta, then the angle between A and minus B becomes pi minus theta in terms of vector. And it is just a coincidence that it looks very nice in terms of formula. So this minus is very sneaky. It's not simple minus. It's not because here minus, so I am putting here minus. No, it's not like that. I mean, I have seen many students, they believe that, okay, minus means minus, plus means plus, and that's how they remember. But this is something very different. I hope you're trying to realize what I'm trying to explain. This is not as simple as it is. So the resultant of A and B, this is the resultant. This is the length of A, this is the resultant of A and B. So I say this length is representing A and B modulus. And this length represent A and minus B modulus. Okay. Now tell me which length is bigger, A and B or A and minus B? Which one is bigger here?
Sir, I think the
Sir,
both are same.
above.
Yeah, so A plus B modulus is bigger than A plus B modulus. So mod of A plus B is greater than mod of A minus B. Okay, is it going to be always true?
No, sir. For
Sir,
right
in case
angles,
of
not true.
right angle triangles.
So it is true. Okay, when it is true, for what angle this can be true?
So 90, 180.
90.
So this
For
can be
what?
true for
Yes.
acute.
Yeah, you are going correct. So that's the right answer. This is true for all acute angles. That is, if the angle between the two vectors is less than 90, then their sum will be bigger than their difference. Let's do the opposite. Imagine we have two vectors whose angle itself is more than 90. So how we will start with? That's very interesting situation. So this is A. This is A vector. And in fact, the B vector is like this. So what is the angle between A and B? This side or the right side? Which side?
So first we have to shift it towards the left.
Yeah.
So
So no,
that
I'm asking which
The
side will
angle
be
is
the
obtuse, right hand side.
yeah, so I will now I'm taking theta as this angle. So now my theta is obtuse. You can see my theta is obtuse in this case, right? So if you look carefully, the resultant in this case turns out to be this line. So this is the resultant of A and B. So this is the A and B. That's simple. But if you make it minus B, so you can see what is minus B.
180 minus theta.
So yeah, it's but this is bigger than 90. So this is anyway pi minus theta, but this is acute angle. So now A and minus B makes acute angle, and their resultant is really big. So this is the A and minus B resultant. And we can see that the A minus B, I will say A plus B, is less than A minus B when theta is more than. So these are conditionals, not always true. So A plus B is less than A minus B when theta is obtuse. A plus B is bigger than A minus B when theta is acute. So when they are going to be equal, is there any case when the sum and difference will be same?
90.
Exactly. Can you draw and understand? Can you realize by drawing it?
Yeah, sure.
So you all draw the right angle for A and B and A and minus B and just realize that they are equal or not. Do it, everyone. So we have someone first timer here, Srishti and Yusuf. Are you guys getting it?
Yes, sir.
So I hope you might have watched the previous lectures because that is having correlation there. Okay. So in fact, I will encourage all of you to go and watch the previous recorded lectures so that things will make more sense to you. Okay, so when A and B makes a right angle, then what you realize?
same.
Exactly. At right angle, both turns out to same. Now, geometrically, we can believe. Now, you can also prove mathematically. Why? If you put theta equals to 90 degree, what will you get? Both equation turns out to be same because cos 90 is 0,
Sorry.
isn't it? So what is geometrically obvious can be proved, I mean, even mathematically, that if theta is 90 degree, then cos 90 will be 0. And therefore, the mod of A plus B is just a Pythagoras. Is only the square and this is Pythagoras, nothing more. And in fact, this is also same. So finding the resultant of two perpendicular vectors is pretty easy. It's just you add square and add. It will follow the Pythagoras. Okay. So now we'll take some cases like begin with this formula R mod like. So there are many ways to represent. I mean, these are some advanced method of representation. This is something very advanced. Okay, these are notations, but in mathematics, what you need to know is this much. So R, A plus B, all are same thing to represent. So this formula A plus B, this is better actually representation, and we write as A square 2AB cos of angle between A and B. Theta is angle between A and B. And therefore, if I say theta is 0 degree, now graphically it's simple. Theta 0 means both the vectors are in the same direction. So you can just add like without doing any calculation. When theta is 0, what do you expect? A plus B will be same as the sum of the length. So it turns out to be sum of the length, right? Because cos 0 is 1 and this is becomes A square plus B square plus 2AB, which is A plus B whole square if you take the root. Is this clear, guys? I think this is
Yes,
obvious. And if theta is 180 degree, then what we can write? A plus B. Tell me.
so minus
What we can write?
sir, that is minus B.
No, tell me completely. You are saying
Sir,
Yes.
opposite direction, hence,
then they will subtract.
yeah, sir.
So when you subtract, then you subtract the big minus small, right? You subtract the big minus small value, but here we don't know which one is big. So the answer could be either A minus B or B minus A. So how to take care of both?
Some mod.
Yeah, so the idea is you cannot write just like this, you have to write the mod because we have no idea which one is bigger. So to make sure that it's a length, we put a mod sign. So it could be anything, A minus B or B minus A, depending on situation. Okay, anyway, so when theta is 180, so the way of writing is A minus B mod. Don't write just A minus B, that's wrong. We have seen already theta is 90, so we have A square B square. Oh, there's one interesting. Theta equals to, let's say, 120 degree. Then
Sir, there, it will be like 2AB upon,
okay, I'll tell you what is cos 120.
So minus
1 by 2.
1 by 2.
Minus 1 by 2.
Yeah, that's a very, very important relation that you must remember. Cos 120 is minus sin 30, and that is minus half. Because if you remember the trigonometry is cos
Conversion. Yes.
90 plus 30, which in the second quadrant, and cos
Minus
becomes
sin.
okay. Anyway, so this is something you need to remember, and therefore the answer becomes slightly interesting. A square plus B square minus AB. That's okay, that's the formula. Now something very interesting. Like I'm going to ask you the resultant, and I'm not going to give you theta, but what I'm going to give you is sufficient to get theta. So let's say find R of A and B if it is known that the R vector is perpendicular to A vector. Now this is like an information, and from here you have to do the reverse engineering to get the theta, and from there you can get the answer for mod of A. So can you tell me this answer? Like practice and do some calculation and tell me the answer. Maybe the geometrically it's very easy, but if you want to do it mathematically, you can do it. I will show you both the methods. So what is A plus B here?
Sir, it's B
Sir, under root A
square
square
minus
minus
A
B
square
square.
under root.
Under root?
B
A
square
square
minus A
minus B
square.
square.
Yeah, it's under root of B square minus A square.
Minus A
That's
square.
correct.
Yeah,
Sir,
sir.
because R will become perpendicular to A, that's why.
So yeah, so R will become, it is again a Pythagoras. The resultant itself is perpendicular to A vector. So if I draw A, first you draw A and then draw R. So how the B should be? The only option for B is being a slant. So we have no choice but to be like this. Then only we can complete a triangle. And therefore, because it's a Pythagoras triangle, so we can write the B square equals to R square plus A square, and if you solve, this is pretty easy. So here the hypotenuse is B. In fact, the resultant is perpendicular to the smaller of the two sides. That's the theorem. You can always remember the resultant of the two will be always, if it is perpendicular, then it is always on the smaller side, not on the bigger side. So B square is R square plus A square. So R is what you said is correct. And in fact, what is the angle between A and B? Is it inside or outside? Right or left?
Outside. So it
Sir,
will
it's
be
out.
90 plus
Half.
angle
It's
between
out.
R
Just
dash and B dash.
so I can say this as alpha because we know how to use, and because A and B are known to us by length, so we can write cos
180
alpha equal
minus
to how much?
alpha.
No, just cos alpha. Cos alpha is how much? What is cos alpha?
So minus
A by
cos
B.
alpha, right?
Sir,
Cos alpha is A by, in this triangle. Cos alpha is A by B, right?
Yeah, sir.
yes, A by B.
And alpha we can write as pi minus theta. And therefore, minus cos theta is A by B. So cos theta is how much?
Minus A by B.
And here minus is saying that it's obtuse angle. That's obvious. Okay, we know why it's minus. And because we know the cos theta, so we can go back to the original formula, which we always know. A square plus B square plus 2AB. And cos theta is minus A by B that we just got. B gets cancelled, and what we left with is A square plus B square minus 2A square,
B square minus A
which
square.
is eventually B square minus square. Now you can see that through various ways we can arrive at the answer. And even though if I don't know this triangle, how I could have got the answer. So now I'll go back to the formula, because alpha, if you remember the angle between the resultant and the vector. So we know that cos of alpha is A plus B cos theta by R, if you remember the derivation. And what I'm saying is, if alpha is 90 degree, okay, I'm not using geometrical construct, I'm just doing mathematically. So it's an abstract way of solving. So if alpha is 90 degree, then cos 90 is 0. This implies the numerator of the cos alpha, that must be 0. Because for this to be 0, the only option is the numerator must be 0. And this will again give you the same answer. Cos theta is minus A by B. And then we can go back to the formula of resultant, which says that A square B square plus 2AB cos theta. And this turns out to be we have done this calculation. So there are various ways in which you can approach a problem and we can solve a problem. Okay?
Hello.
Yes. So I hope this is clear to all of you. Let's do some more problem.
Sir, can you show the previous page?
Yes, I can show.
Sir, and here can you explain that theta is equal to 181 of once?
The sum of angle of a line is 180 degrees. So this entire angle is 180.
Yes, sir.
So theta plus alpha is 180. So alpha we can replace by
No, sir, I'm asking that, sir, left side of the page you have written. No?
Where?
Here, sir, this part.
Here.
Yeah, sir.
Which one? This one?
So that left box.
This one?
Yeah, sir.
Okay. This is the answer for the if the theta is 180 degree, then if you apply the formula, the what you get here? Let me write down. This is separate question.
Sir, if
So
theta is 270, then
you know what to do. Just substitute the value. And cos 270 is again 0.
yeah, sir.
But the rule says that angle between two vectors must be less than or equals to 180. Okay. So we take the angle which is less than equals to 180. We don't take the angle beyond that. So angle between two vectors cannot exceed 180 degree. Remember it. I must have written somewhere. Okay, now someone has asked this question. A square plus B square plus 2AB cos phi. And this is A square. Cos phi is minus 1. Now how we can write this? A minus B whole square or B minus A whole square, because both are same. So the answer in such case we have to write as a mod because we don't know which one is bigger. That's why we have done like this. Clear?
Yes, sir.
Okay, so let's do some problem. So I will give you some triangle and you will see the how it looks like. So let me draw some random triangle, maybe like this. So if A and B are equal to 1, what is C length? What is the length of C? Tell me guys, what is the length of C? A length is 1, B length is 1. So what is the length of C?
Sir, A is under root A square plus B square plus AB. Or yeah,
The
plus AB.
length is given 1 now. So tell me the answer.
Sir,
One
for
is-
1, okay.
Yeah.
Sir, under root 3.
Are you sure? What is the angle between A and B?
Sorry, sir, 1. Answer will be
Hello,
1,
sir.
1. Sir, it is 1
Yes.
actually because
Yeah.
it is
In
60
fact,
equivalent.
there is no need to solve actually. You can see it's the equilateral triangle. So all sides are supposed to be same. So even the C is 1, right? But okay, let's say the intuition doesn't work. So you how to do it mathematically. So first looking at the triangle, it's very trivial question, but still it will help you in solving tough questions. So first of all, looking at the triangle, can you tell me the triangle law here? What is the triangle law here? Which is equals to sum of the other two? What can I write here? Quickly.
Hello, sir.
Yeah.
Sir, I got disconnected. Can you tell what the question? What?
Question is, we have this diagram shown. You can see the vectors, you can see the angle. Given that the length of A and B, or the modulus or the magnitude is 1, find the length of C.
Sir, it would be one only. It's equilateral.
Yes, that's the right answer. So now what I'm asking next is, can you tell me the triangle law here? What is the law here?
Sir,
Triangle.
Which
yeah,
one is the
sir.
resultant? Okay. Among A, B, C, which one is behaving as a
C.
resultant?
C.
Sir, C.
Very
Because
good.
C is originating from A
Yeah,
vector.
C is having reverse direction. C is A plus B. So if I
Minus
take,
AB.
yeah, if I take modulus both sides, I can add mod of A plus B. This is how we start. And because we know the angle between A and B, so I have to put A and B here. So now what we do is we apply the formula. A square B square 2AB into cos of angle between A and B, which is 120 here. And this turns out to be under root of 1 plus 2 minus half. So this is really mathematically it's lengthy. So this is how you proceed from very basic. So let's do another sum. Okay, so I'm naming it. So what is given to you is okay. So no, yeah. Tell me the mod of C, length of C. There are various ways of solving this, but the vector is one of the ways. You can solve by the sine law, you can solve by the cosine law of trigonometry, or you can solve by vector, which is eventually a cosine law. So if you realize that vector equation, the formula which we derived is basically a cosine law. So you will realize later on. Are you guys solving this?
Yes, sir.
No.
Sir, 3 root 3 minus 3 root 3.
Maybe let me check.
Sir, angle would be that only, not 30, because tail to tail. So, hello, sir.
Yes.
Sir, so what I, sir, can I see what I do?
Pardon?
Sir, I got a quadratic equation at last, so that's why I got it.
It's simple now. First of all, tell me what is the triangle law here? What is the triangle law here?
Sir, A is the resultant, is equal to B plus C.
So
Then I
now,
took mod at its side.
no. No, the problem is we do not know the angle between B and C. What is given to you? Angle between A and B is known to us. So what we'll do, we separate B on the other side because we know the relation between the two. And now because C is in isolation, now we can take modulus. And we know the formula because we know the angle between A and B. So we can write this formula. This formula is known: A square B square minus X. I can write directly because this is going to be minus 2AB cos theta. Here theta is 30. So I think everything is given to us. Let me substitute 9 square 81 36 296 cos 30. Okay, so that's really bad value. So what I can do to make it to better value? Maybe I can make it 60 degree. Is it okay? 60. No, that's will give me negative answer. No, that's fine. So anyway, whatever we are getting is getting. That's okay.
Sir, I got this answer
Yeah. So whatever
by
it is
sine
there,
law.
so you can just substitute and you can get the mode of C here. 81 and 36 is how much? 83, 110 and
117.
and then this is 296. That's the answer. Okay, so this is how we proceed. Like whatever is known to you, you try to segregate the terms which gives you the known value, and then take the mod and then write the formula, and then get the answer.
Sir, I did the opposite way, sir. Sir, then, oh, sir, 9 means I took that 9 is equal to 36 plus C square plus 2 into 6 into C into cos 30.
So you got the quadratic then.
Sir,
Yes, sir.
Yeah. So if you solve the quadratic, you will get the same answer, but that become really hectic.
Sure, but I got
not
simple
very-
answer. But it is negative, sir.
sir, I got 6 upon 3 minus root 3.
So you have to ignore the C. The length cannot be negative. So you have to ignore the negative sign.
Hello, sir.
Sir, but answer will be same in both case.
Yeah.
I
Answer will
took
be
C
same.
as variable then.
Answer will be same.
Sir,
Mhm.
sir, I did by sine law, sine rule, in which, sir, I took C mod C vector upon sine 30 equals to B vector.
See, the problem is you can't use the sine rule because for using sine rule, you need to know at least two angles.
Yeah, sir. Actually what I did was I know I was known with one angle which is 30 degree. So A plus B plus 30 equals to 180 in a triangle. So A equals to 180 minus 30 plus B.
Yeah, that's fine.
Right. So I substituted A in the place of A. I substituted 180 minus 30 plus B. So it is nothing but sine 30 plus B. So sine 30 plus I had put it in the formula of sine 30 plus B, which is sine 30 plus cos B. Sorry, sine 30 cos B plus cos 30 sine B. Then afterwards I solved it in the both LHS, RHS, and then solved it again and again. And my answer at the last came 3 minus root 3. Let's see.
Okay.
Sir, this answer is coming means 117 minus 54 root 3 and the root is coming 4.8, and so my answer is coming 5.1.
So of course your answer is not correct. Okay, anyway, don't worry. So okay, proceed with the way what you have learned. So try to stick to the vector method. Okay, and the moment things are right angle, you can go back to geometrical way of solving. So I'll give you a set of questions today, probably in the evening, because that time I'll be
Sir,
free.
I want to know it.
Yeah.
Oh,
What do you want
sir,
to
I want
know?
to know. Sir, last that question we saw.
Sir, my answer is coming 4.7349 like that.
Okay, you have
Sir,
understood this method, the way we have solved here. Okay,
Yeah,
if you want
sir,
to if you want to solve by other method, it's not very difficult, but it's like you need to do a lot of trigonometric manipulation. So vectors are somewhat a way to write things explicitly, and then always rearrange in a way that you know something about it. So let's say here the angle between A and B was given, so that's why I rearrange like this. So if something else would have been given, I would have arranged differently. The entire idea is to play with the things which is known to us and try to find the unknown using the same. Okay, so that is the idea. Okay.
sir, noted.
Yeah. All right,
Sir,
guys. So
I have to rotate.
okay, you can write down. Then I'll end this lecture. I have another
Sir,
lecture.
what was the mistake in my solving method?
You just send me. You just send me. I'll see. WhatsApp me. I'll see. Don't worry.
Sir, means it's easy, sir, means where you substituted that C is equal to A minus B, sir, I solved directly from A vector is equal to B vector plus C vector, keeping C as a variable, and then I got like a quadratic equation.
No, something is wrong. I know what you have done wrong, but you just send me. I'll just see once again, and then I'll comment on it. Okay. So just finish writing this, guys. I have to end the lecture. I have to start another lecture. So anyone else like finding anything difficult in today's lecture? You can ask. Then I'll clarify before I leave. I think we have two newcomers, Shristi and Yusuf. You guys having any trouble today?
No, sir.
Okay. Yusuf, you have any trouble?
No, sir.
Okay, that's
Sir,
it.
I sent you.
All right. So I'll comment on that. Don't worry. So okay, bye guys. Take care, and we'll meet again in the next class. I'll give you homework today by end of the day, hopefully, and you can start practicing those questions. It's really easy, not difficult, and we'll try to move forward and fast forward also. Fine. Thank you guys. Bye.
Thank you, sir.